Okay, good morning class.
Good morning, sir.
So today we're looking at exponents. It's basically the fourth lesson. So we're looking at the examples for exercise 2.4 on page 46. Okay. So up until now all our exponents has been integers. For now, we now introduce new definitions to allow us to work with rational exponents. Some definitions for rational exponents. People, when you were grade 9, we exposed you to these laws already. Okay, so as you know, there are many new grade 10s here. It's probably you didn't touch on this last year. So for the benefit of them, we're going to just go through it again. So for n is an element of natural numbers, and n has to be greater than 0. You see, this n here is natural numbers. Natural numbers, and that n denotes the denominator. Okay, so it's different. For n is greater than 0, m is an element of integers, and a is greater than 0. We are told that a to the exponent 1 over n can be written as the nth root of a to the 1. You see that? Goes there. Okay. You all understand it? Your friends in maths little. But anyway. Okay. So they're not working, so they're not knocking on these doors. So we got a to the minus 1 over n. Okay. So that would be the nth root of a to the minus 1. And of course a to the minus 1 can be written as 1 over a to the n, if needed. Not so?
Yes, sir.
So if you have a negative exponent, you can write it as a denominator. Okay. Oh, just a. Sorry, not a to the n. Oh, is that why you went on that? Okay. People, the next one is the mth root. Is a to the exponent m over n can be written as the nth root of a to the n. So if here you got a to the exponent 2 over 3, that can be written as the cube root of a squared. You all understand? Okay. With these definitions, all the laws of exponents also hold for rational exponents. So all that where we say, when we're multiplying and bases are the same, we add the exponents. When we divide, we subtract the exponents. If something raised to a higher exponent, we multiply. All of the rules that applies previously still applies. Okay? That's what they're saying. So let's look at this question here. So here we got 2 to the exponent a half. Okay? So this can be written as what? In a radical form or third form? It can be written as the square root of 2. Remember, that is always the root. And that is, this exponent remains there. So in simpler forms, it can just be written as the square root of 2. Okay. Let's look at 8. What can happen to 8? Can be written as 2 to the exponent 3. Raised to the exponent negative 1 over 3. You all agree with that? Yes. See anybody that's confused? No? So you got 2. What is 3 times negative 1 over 3? Negative 1. And 2 to the negative 1 can be written as 1 over 2. Okay. There's of course many other ways I could have done this. Let's just look at another way. If I got 8 to the exponent negative 1 over 3. This can be written as the cube root of 8 to the negative 1. Okay. 8 to the negative 1 can be written as what? 1 over What's the cube root of 1? The cube root of 8? Same thing. So whichever way you want to use or apply, it's fine, okay. Let's look at the next example. Please settle down. Look at the next example. It asks you to simplify 4 to the exponent 3 over 2. 4 to the exponent 3 over 2. Now this can be written as, 4 can be written as 2 squared raised to the exponent 3 over 2. So what is 2 over 1 multiplied by 3 over 2? 3. And 2 cube is? Okay, that is one way. I could have also said that 4 to the exponent 3 over 2 can be written as, that will be the root. So it's the square root of 4 cubed. What is 4 cubed? 4 times 4 times 4? So the square root of 64 is? The one is easier than the other for you. Okay, some would apply the other one easier, find the other one easier. No? So again, you can apply any of the two methods. Okay. Let's do this one. What will this be? It will be 2 squared, he says yes. Raised to the exponent, 2 over 3. So when you're multiplying and bases are the same, what do we do to the exponents? We add it, okay. Something raised to the higher exponent. What do we do to the exponents? Multiply. Lisa? Are you okay? Must look here, Michael. Don't tell me later on that you don't understand everything. No? So you weren't looking. What's 2 times 2? 4 over 3. So that's 2 to the exponent, 4 over 3. But this can be written in third form or radical form as the cube root of 2 to the 4. So what's 2 to the 4? 60? 16. Okay. So it's a cube root of 16. Okay. And of course there's more ways that we can represent that answer, but then more of that we do in grade 11. Okay. So now we're looking at using the laws of exponents, which is also on page 45 for exercise 2.4 on page 46. We assume that all the denominators are non-zero and the variables are positive. People, if the denominator was 0, then what's wrong with it? It will be undefined. Okay, sums will be undefined. Okay, so let's look at the first example. Under this topic and this heading. The rule says when we're multiplying and bases are the same, what do you do to the exponents? Add. So that will be 8 to the exponent 7. Raised to the exponent negative 2. If something is raised to a high, if a base is raised to a higher exponent, what do we do? Multiply the exponent. So 7 times negative 2? Negative 14. People, naturally this is over? So I bring this down. So it's 1 over negative 14. Okay. You all okay with that? So look at the next one. What do you notice here? We've got 2 to the exponent 2x times 3 to the exponent 2x. What do we notice here? Exponents are the same. Not so. So if I had 2 to the x times 3 raised to the exponent 8, and I simplify this, what would it be? 6 to the 8, not so. Or, if I got rid of the brackets first, what would it be? 2 to the exponent 8 times? So 2 to the 8 times 3 to the 8 can be written as the same exponent. Not so. In turn, which can be written as 6 to the a. So if I apply that the rule here, what would it be? Is 2 times 3 to the exponent? 2x. Not so. And what is 3 times 2? 6. So it will be 6 to the 2. Okay. The next example. State whether the following mathematical statement, which is a squared b cubed equals a b to the exponent 6. True or false? False. Why? Because when we're multiplying and bases are the same, we add the powers. Are the bases the same? No, so I can't add the powers. Okay, so how do we do this? We say let a equal 1 and b equal 2. Then what will it be? The left hand side would simply be, we was here a up with the 1. So 1 squared times 2 cubed. Not squared, cubed. So that's simply 1 times 8. And 1 times 8 is? Let's look at the right hand side. So that would be 1 times 2 to the exponent 6. So 2 to the 5 is the 6 is 64. No? So it's 1 times 64 is equal to 64. Therefore, the right hand side is not equal to the left hand side. Okay. Next. So here we got in brackets 2a squared b cubed raised to the power 2 times ab to the exponent 4 raised to the exponent 3 over or divided by 2a cubed b squared all raised to the power 4. So what's the first thing we need to do here? To get rid of the brackets. Okay, so it's going to be 2 to the exponent 2 times a to the 4 times. Okay, we don't need the times then, yeah? So it's 2 squared a4 b6 times a cubed b12 over 2 to the 4 a12 b8. People, what is 2 squared? 4. Okay, and 2 to the 4 16. So it's going to be 4a. Now what I'll do is I'll multiply the top in the meantime. It's a7 b18 over 16 a12 b8. 4 goes into 4 once, 4 goes into 16 4 times. We are the more a's? Bottom. A5, where's the more b's? Top will be b to the. For that, people, you should be able to do exercise 2.4. Okay. People, please hang on. Please have a seat. Enjoy the rest of your day, people. Good afternoon, class.